Hello everyone, myself Kirtana Ji. Today let us know about the quicksort based on the design and analysis of algorithm. Moving on to the contents, introduction to quicksort, how quicksort works, pseudocode of the quicksort, time complexity of the quicksort, advantages of a quicksort and conclusion. Introduction to the quicksort. Quicksort is one of the most efficient sorting algorithm out there. Sorting is an essential task in a computer science and it is crucial to have an understanding of the different sorting algorithms available to us. Quicksort is a popular algorithm that has stood the test of time and continues to be widely used today. In this presentation, we will explore how Quicksort works, its advantages, and its time complexity. Quicksort was invented by Tony Eury in 1959 and since then it has become a staple in computer science education. It is a divide and conquer algorithm that sort an array by partitioning it into a sub-arrays according to the pivot element. The pivot element is chosen and the element in an array are arranged so that elements smaller than the pivot element comes before it and larger elements comes after it. This process is recursively applied to the subarrays until the entire array is sorted. Now let us dive deeper into the working of quicksort. Now let us know how quicksort works. We know that quicksort is a sorting algorithm which uses divide and conquer approach to sort an array or to sort a list of elements. The algorithm works by selecting the pivot element from the array and partitioning the elements into two subarrays, whether they are lesser than or the greater than the pivot element. The subarrays again they are partitioned into a two subarrays and they are sorted according to the same method. The key of the quicksort is the selecting the pivot element which can greatly affect the speed of the algorithm. A good pivot should be chosen such that the dividing an array roughly should be equal to half and minimizes the comparisons need to be sorted. There are several methods for choosing a pivot, including selecting the first or the last element, choosing a random element, or selecting the median of the three random chosen elements. Now let us move on to the pseudocode for the quicksort. Firstly, select the pivot element from the array or the list of an element. Secondly, partition the array into subarrays such that the elements greater than the pivot element will be on the right, then the smaller than the pivot element will be on the left. Repeat the step 1 and step 2 to the subarrays and on the left and the right of the pivot element. Continue until the subarray size is 1 or 0. It is an important to note that the choice of a pivot can greatly affect the efficiency of an algorithm. A good pivot should divide the array into roughly equal parts, which can be achieved by choosing a random element or a median element. This is the implementation of a program where we'll define a quick sort of an array. If the length of an array is less than or equal to 1, we'll return uh, array. Else the pivot will be equal to array of 0, left will be equal to array, right will be equal to array. For I in the range of 1 length of an array, I will be initial I is to 1. If array of I is less than pivot element, add the elements to the left, else add the elements array of elements to the right or else return the quicksort left plus pivot plus quicksort right. This is the problems that explains how the quicksort works. First step 1 is determine the pivot. Step 2 start pointers at the left and right. Since 4 is greater than 3 stop. Step 3 since 5 is greater than 3 shift right pointer. Since 3 is equal to 3 stop. Step 4 swap the values of the pointer. Step 5 move the pointers one more step. Step 6 since 2 is less than 3 shift left pointer. Since 4 is greater than 3 stop. Since left pointers is pass, right pointers stop. Moving on to the time complexity of the quicksort. For the average case, the time complexity of the quicksort is O of n log n and for the worst case is O of n square. We know the quicksort is one of the most popular, fastest sorting algorithm available for especially for the larger data set and the worst case scenario can make it inefficient for certain use cases. When we compare to the other sorting algorithm, quicksort performance in terms of time complexity is more. For example, In a merge sort, the average time complexity is O of n log n, and but it requires a more memory, that is additional memory space for merging process. When it becomes to the insertion sort, it has a worse time complexity of O of n square, making it slower than the quick sort in based on the larger data set. Advantages of the quicksort. One of the main advantages of the quicksort, it is efficient. It has an average case time complexity of O of n log n, which makes it one of the fastest sorting algorithm out there. It is especially important when dealing with larger data sets. A quicksort can handle them much more quickly than other sorting algorithms. Another advantage of a quicksort, it is versatility. It can be used as a sort as a wide range of data type, including the integer, floating point number, and even strings. It makes it useful tool for many different applications from database management to a scientific research. Moving on to the conclusion. In conclusion, Quicksort is an efficient and versatile sorting algorithm that has become a fundamental tool in a computer science. Its ability to handle large data sets quickly and its adaptability to different situations make it an essential part of a programmer's toolbox. Throughout its presentation, we have seen how Quicksort works, examined its time complexity, and explored its advantages over the other sorting algorithms. We have also highlighted the importance of understanding a quicksort and its application in the computer science. As we move forward into the future of technology, it is crucial to continue developing and improving upon the algorithms like quicksort. By doing so, we can ensure that our systems are running efficiently or effectively, paving the way for even greater innovations and the progress. This is all about the quick sort. I hope it was informative. Thank you.